In E part of lecture first, in today's lecture we will cover the reduction formula for integration secant nx dx and integration cosecant nx dx, and these question 9 to 11, three important questions which are asked in your examination. We already solved the question 1 to 8 in lecture 1, the various part, that is part A to E. So in today's lecture we successfully solved these 9th, 10th and 11th, and these are very important questions. Mainly this question number 10. This is asked 3 or 4 times in Kushetra examination. The question 9th is to find the reduction formula for integration secant nx dx, and there is you have to evaluate integral for value of n is equal to 6, that is integration secant 6x d of x. Now we first draw this reduction formula, then we will solve the question number 10. So for this integral, we will first split our first term as secant n minus 2x and secant square x d of x. Okay? So I am first splitting this term and like this. Now I am applying the Euler formula, the first function and second function. तो Euler formula क्या लगता है आपका, मतलब integration by part. तो this is first function, this is second function. First function as it is integration of this second function minus integration differentiation of first function, that is here, integration of this second function which is here, and d of x. Now the integration of secant square x, this is tangent x, so I am writing it here, this term as it is, integration of this term tangent x here, minus differentiation of this term, so you will take power out आगे and then diminish by 1, so this gives n minus 3 power here. Now inside function, so inside function is your secant x, so you will multiply differentiation of inside term, that is secant x. And what is the differentiation of secant x? That is secant x into tangent x. This part is due to this differentiation. Okay. Then integration of secant square x, which is tangent x. So this part is here and this integration is here. Now you can take this term outside. This gives you secant n minus 2x and this is tangent square x. So my integral becomes this term. Now you can write this term as secant square x minus of 1. I am using this identity here. So this term secant n minus 2 x here as it is. This term is also as it is, minus sign this n minus 2 integration. This is secant n minus 2x and in place of tangent square x you will write secant square x minus 1. Now you can multiply this with this term and this with this term. This minus sign, this becomes plus sign. So on multiplying this with this term we obtain this integral. So my left hand side is integration secant nx dx is equal to this term and this term multiply here. It is minus sign secant nx dx. This minus with this one minus gives you plus sign and n minus 2 secant n minus 2x dx. Now the value of this integral, it is same as your left hand side. So I am taking this on the left hand side and taking the integral outside. So it gives me this expression. Okay. So 1 plus n minus 2 integration of secant nx dx. First write this one. Okay. And this term I wrote here the same time, same here, and this minus ये आप इधर ले जा चुके हैं, तो this plus n minus 2 integration secant n minus 2x dx. When I simplify this, it is n minus 2 plus 1, so it means n minus of 1. Divide the whole term on the right hand side by this n minus 1. So here becomes 1. So this is integration of secant nx dx. This term as it is, and the right hand side becomes secant n minus 2x, secant n minus 2x, tangent nx. This term divide में तो n minus 1 plus n minus 2 by n minus 1 and integration secant n minus 2x d of x. Now if you take your left hand side as in integral, if I take this notation, so your reduction formula for secant nx dx becomes, in place of this one I will write in equal to secant n minus 2x tangent x upon n minus 1. This is n minus 2 upon n minus 1. In this integral, if I take here n, so this gives in. If I take n minus 2, so this integral will be equal to I of n minus 2, as we have done in tangent nx and cot nx. So my integral value of this one is I of n minus 2. Now to derive the deduction part, integration of secant 6x dx, I will put n is equal to 6 in this equation. Suppose you are taking this is equation number, suppose this is 1 here. Okay, so put n is equal to 6 on the left hand side and on the right hand side. Then I will put 4 and then I will put 2 in this equation. So when I put n is equal to 6, I6 is equal to secant 6 minus 2 is 4 tangent x upon 6 minus 1, that is 5, upon this is 6 minus 2 4, 6 minus 1 is 5, I of 6 minus 2 it is I4. So I wrote it equation number 2. Now I am putting again n is equal to 4 in this equation 1. So I obtained on the left hand side is I4 is equal to secant, this is 2 tangent x and 4 minus 1 is 3. Okay, plus this plus sign here, n की value क्या put कर रहे हो, you are putting here 4. So this is 4 minus 2 is 2, 4 minus 1 is 3 and I of 4 minus 2 is 2. Now again putting, here is the condition, you can apply here condition n is not equal to 1. That's why I am putting here 4, 6, 4 and 2. So put n is equal to 2 in the equation 1 again. Here I obtained secant, this is 2 minus 2 is 0 dot, यहाँ पे आप क्या करोगे tangent x और नीचे 2 minus 1 is 1. And this expression 2 minus 2, this term becomes 0. I of naught you can calculate, but there is 0, so I am writing here 0. Now I am putting this I2 in this equation. So I4 is equal to secant square tangent x upon 3 plus 2 by 3 tangent x. So this term is my I4. Now I am putting I4 in equation number, here I will put it into equation number 2 to get the I6. Okay, so to put this value in this expression here, so I4 थी आपको मिला, I6 is equal to secant 4 tangent x upon 5 plus this is 4 by 5 and in place of I4 you will use this term. मतलब आपको यहाँ ये term आपको put करनी है in place of I4. तो this is 4 by 5 and I4 ये value मैंने उठा के यहाँ रख दी. तो multiply this term with this and this term with this. So when you simplify, this gives you, this term will remain the same, secant 4x tangent x upon 5 plus this is 4 inside, 5 3s are 15 secant square x tangent x plus 4 2s are 8, 5 3s are 15 and this is tangent x. So it's the required answer for the integral secant 6x d of x, and hence it is required. So answer is this one. Now the next question. The question 10th, obtain the reduction formula for integration 0 to pi by 4 secant nx d of x. First we will evaluate this reduction formula and hence evaluate means आपने जो आंसर निकाला है you will use that and then calculate the value of this integral, not directly. ठीक है. Now to find this reduction formula in this question and this question only the difference of limit. So half of the question I will use from the question number 9th, which I already solved up to equation number 1. So I again write the equation 1 here, which is integration secant nx dx equal to secant n minus 2x tangent nx upon n minus 1 plus n minus 2 upon n minus 1 integration secant n minus 2x dx. What is this? It is reduction formula of integration secant nx. Now take the limit of x 0 to pi by 4 both side, because we want to find this integral. So for this there is a need of limit. Our limit is from 0 to pi by 4. So take the limit both side 0 to pi by 4. My integral becomes, my expression becomes, here I will apply the limit 0 to pi by 4. This value is same. Integral 0 to pi by 4 inside term is, in the integral is same. Now what is the value of tangent pi by 4? Tangent pi by 4 is 1 and secant pi by 4 that is under root 2 है ना. तो you will use this value. तो upper limit इसमें आपको आंसर देगा क्योंकि pi by 4 है, both are non-zero, but when you put the lower limit secant 0 is 1 but tangent 0 is 0, so the lower limit contribution here is 0. So I wrote this. First I put the upper limit minus lower limit and this integral as it is. As I told, secant pi by 4 that is under root 2. So here under root 2 power is n minus 2 and this term n minus 1 is here. Tangent pi by 4 becomes 1. So I am not writing it here because this is 1 plus n minus 2 upon n minus 1 and this integral 0 to pi by 4 secant n minus 2 x d of x. Now if I define this is a new integral, suppose I n dash, then this is it is the reduction formula for I n dash, and let us suppose this is equation number 2. ठीक है, तो I can write the reduction formula this one. तो आप इसे भी कह सकते हैं, इसे भी कह सकते हैं. तो I am writing this is 2 and this is 2a. This is in the integral form, this is in the symbolic form. Now to find the reduction part, evaluate. So I have to find this integral here 0 to a square plus x square 5 by 2 d of x. So here is a plus sign, so sin theta is not applicable here. So we think about the identity such that this reduces to into the reduction form. So I am putting x is equal to a tangent theta. Then I need d of x also. So differential both sides. So it gives a tangent is secant square, yes, and theta is d theta. Now I want to change the limit also. When x is equal to 0, a तो 0 है, नहीं तो tangent theta is 0. When tangent theta is 0, the limit for this one is theta is equal to 0. Is it clear? ठीक है ना? Then x is equal to a, तो यहाँ put करिए a by a 1 tangent theta. तो for what value of theta? Tangent theta is equal to 1, so theta is equal to pi by 4. So my limit on making this substitution becomes 0 to pi by 4. So I am putting this value in this integral. So this integral is equal to a square plus a square tan square theta 5 by 2 and this is a secant square theta d theta 0 to pi by 4. Now taking a square outside and the power is 5 by 2. So it is a की power 2 pi by 2. This is a की power 5. 1 plus tan square theta power is 5 by 2 and this a is as it is secant square theta d theta. here is a की 5, here is a की 1, so it gives you a की power 6. It does not depend upon theta, so I am taking it outside the integral. So it is now this left hand side equal to a की power 6. The limit is 0 to pi by 4 1 plus tan square theta. This is secant square theta. Good. So secant square theta power is 5 by 2. ठीक है, and this is secant square theta d theta. So secant square 5 by 2, 2 to 2 cancel. So this is secant 5 by secant 2 into 5 by 2 ना, तो secant 5 theta. ठीक है, and this is secant square theta. तो value of this integral is क्या बनेगा आपका secant 7 theta d theta. तो your integral here is nothing but a की power 6 I7 dash. Why I am putting I7 dash? Because in second A equation I defined this integral 0 to pi by 4 secant n theta d theta is in dash. So relating to that, this is nothing but a6 I7 dash. So suppose this is equation number 3. Now I will first calculate this one and then put values in equation number 3. I obtain the required answer. So for this, put n is equal to 7 in equation number second A. Okay, I will show this. Your second A equation is this expression. So I7 dash is equal to under root 2. 7 minus 2 is 5. So I am writing it here under root 2. Power is 5. This 7 minus 1. This is 6. Plus 7 minus 2, 5. And this 6. And I of 7 minus 2 is 5. So this is equation number, suppose you are 4. Then I want to find this integral also. So put again n is equal to 5 in equation number 2a. So it gives you I5 dash. This is, देखो आप पुट कर सकते हैं इसमें. Here in place of n you will put the 5 as you already put in tangent quotients and cotangent quotients. Same line you will put under root 2. This is 3 by 4 plus 3 by 4 and I of, यहाँ 5 minus 2 करेंगे तो कितना आंसर आएगा 3 dash. Now I again need the value of I3. So put again n is equal to 3 here. So I3 dash is equal to under root 2. 3 minus 2 is 1 by 3 minus 1 is 2 plus 3 minus 2 that is 1. 3 minus 1 2 and I of 3 minus 2 is 1. So write these equations as equation number 5, equation number 6. Now to evaluate this I7 dash, I need this one which is this. I need this one which is this. So here I need I1 dash. So I will put n equal to 1. N equal to 1 I will put in this expression. So I1 dash is equal to 0 to pi by 4 secant 1 x dx. Now I need this integral. What is the integration of secant x? And it is log of mod of secant x plus tangent x. ठीक है ना? Now put limit 0 to pi by 4. First I will put secant upper limit which gives you log of mod secant pi by 4 plus tangent pi by 4. आप mod ना भी लगाएं, reason being the inside term in the first quadrant all the trigonometric functions are positive, so you can eliminate this mod function here. So log of secant pi by 4 plus tangent pi by 4 minus secant 0 is 1 and tangent 0 is 0. Secant 0 1 होता है but log 1 is 0. So the contribution of lower limit here is also 0. So it gives secant pi by 4, its value is under root 2. So log of under root 2 plus 1. Now put I1 dash value in equation number 6. ठीक है, आपकी 6th इक्वेशन ये वाली थी. तो आई एम पुटिंग द एक्सप्रेशन ऑफ I1 dash in equation number 6. So I3 dash now becomes under root 2 by 2 plus 1 by 2 log of this value, under root 2 plus 1. So suppose this is equation number, if you want you can write equation 7, otherwise no need. Okay, now put I3 dash in the equation number 4, and equation 4 was this one. Okay, so it gives I7 dash, which is nothing but I5 डैश. तो एक्चुअली क्या है कि मैं इसमें डायरेक्ट पुट कर रही हूँ क्योंकि आप प्लस का साइन है तो इसमें हो जाएगा. देखो I7 में अंडर रूट 5 बाई अंडर रूट 2 की पावर 5/6, दिस टर्म एज दिस प्लस 5/6. हेयर आई नीड दिस I5 डैश. व्हाट इज द वैल्यू ऑफ I5 डैश? अंडर रूट 2 की पावर 3/4 प्लस 3/4 ये वाली, एंड वैल्यू ऑफ I3 डैश. I3 डैश कितना है? अंडर रूट 2/2. ठीक है, दिस टर्म एज इज प्लस 1/2. दिस इज लॉग ऑफ अंडर रूट 2 प्लस 1. नाउ अंडर रूट 2 की पावर 5, दिस इज 2 इंटू 2 इंटू अंडर रूट 2. 2 2 जा 4, 4 अंडर रूट 2/6. ठीक है, प्लस this 5/6 is outside, so I'm taking this inside, and under root 2 power 3, this is 2 under root 2 by 4. This is plus sign, this term multiply this, so 5 into 3 upon 6 into 4, this curly bracket as this. So it is under root 2 by 2 plus 1/2 log of under root 2 plus 1, this term. Now on simplification, 2 2 ja 4, 2 3 ja, so 2 under root 2 by 3, it gives 2 2 ja 6 2 ja 12, 5 under root 2 by 12 plus 5 3 ja 15 and 6 4 ja 24. 2 I am taking outside, so this gives 48. So this term with this one, 15 under root 2 by 48 plus 15 by 48 log of under root 2 plus 1. Now you can take the LCM of these three terms, which is 48, and simplify. It gives you this equation. So more further simplifications, this term is written as 67/48 under root of 2 plus 5/16 log of under root 2 plus 1. Now on substituting this expression I7 dash in equation number 3, put in 3, I obtained the integration 0 to a. This is a square plus x square. The power was 5/2 d of x. This integral is equal to, there was a की power 6, so a की power 6, and this integral as it is here, 67/48. So it is a required answer. ठीक है, so now you can use reduction formula to find the various integral. Now the last question of today lecture, that is question number 11. Question 11th is derive reduction formula for integration cosecant nx dx. Hence derive the same, मतलब आपको reduction formula derive करना है, but the limit of the integral here is π/3 to π/2 cosecant nx d of x. Also evaluate this integral by replacing n by 3. There may be in the examination 2, there may be 5, there may be 7. ठीक है, तो आपको ने क्या करना है, ऑन द सेम लाइन जैसे आपने सीकेंट nx का रिडक्शन फॉर्मूला ड्राइव किया, ऑन द सेम लाइन हम ड्राइव करेंगे कॉसिकेंट nx d of x. ठीक है, तो इसे कैसे स्प्लिट करेंगे, कॉसिकेंट n-2x इंटू कॉसिकेंट स्क्वायर x. नाउ इंटीग्रेट दिस टर्म, यानी कि इंटीग्रेशन ऑफ कॉसिकेंट n-2x इंटू कॉसिकेंट स्क्वायर x dx एज इंटीग्रेशन बाय पार्ट. ठीक है, फर्स्ट फंक्शन एज टे, दूसरे का इंटीग्रेशन, तो इसका इंटीग्रेशन कॉट माइनस कॉट आ जाएगा. ठीक है, देन इंटीग्रेशन डिफरेंशिएशन ऑफ फर्स्ट, इंटीग्रेशन ऑफ सेकेंड, एंड देन टेक सिंप्लीफाई इट. वी ऑब्टेन द रिडक्शन फॉर्मूला फॉर cosecant integration of cosecant nx dx is equal to minus cot x cosecant n-2x n-1 plus n-2 upon n-1 integration cosecant n-2x d of x. similar as we done for secant nx. ठीक है, तो write down this is equation number. Again for this question I am writing the equation from 1 to so on. ठीक है, तो my integral formula, if I take your left hand side as integral in, तो in is equal to this term as it is, this is as it is, and in place of this integral I can write I of n minus of 2. Got this? Okay. Now for the reduction part, my limit of integration is pi by 3 to pi by 2. So I will put limit pi by 3 to pi by 2 in equation 1. ठीक है, तो लेफ्ट हैंड साइड becomes pi by 3 to pi by 2 cosecant nx d of x, which is equal to here minus cot x cosecant n minus 2x upon n minus 1, limit I put it here pi by 3 to pi by 2. This value as this, here the limit is pi by 3 to pi by 2 cosecant n minus 2x d of x. ठीक है, now cot pi by 2 is what? This value is 0 and cosecant pi by 2 is 1. ठीक है, अपर लिमिट तो आपका 0 और 1, तो ड्यू टू पाई बाय 2 cot pi by 2 द कंट्रीब्यूशन ऑफ अपर लिमिट हेयर बिकम्स 0, फिर माइनस साइन आएगा. ठीक है, फिर हमें पुट करना है पाई बाय 3. पाई बाय 3 मीन्स 60 डिग्री, तो cot 60 कितना हो जाएगा? cot pi by 3 तो 1 by under root 3. ठीक है ना, एंड cosecant pi by 3 this is 2 by under root 3. तो make this limit here. So this integral is equal to 0 to pi by 3 cosecant nx dx लेफ्ट हैंड साइड, अपर लिमिट की वजह से 0 हो जाएगा, फिर माइनस साइन एंड दिस माइनस साइन गिव्स यू प्लस साइन. This n minus 1 is as it is because you are putting the limit in place of x. Now I am putting the lower limit. The cot pi by 3, it is 1 by under root 3 into में cosecant, this is cosecant pi by 3. The whole power is n minus 2. तो यहाँ पर जो पावर लगेगी ना n minus 2, तो this is 2 by under root 3 की पावर n minus 2 plus sign, this term as it is, this limit is as it is. ठीक है, now simplify 1 over n minus 1, I wrote it here. This term is as it is, under root 3 here, under root 3 की power n minus 2 and 2 की power is again n minus 2 and this term as it is, and I am supposing this is in dash and this becomes then in minus 2 dash. ठीक है, तो ये आपका इक्वेशन नंबर 2. नाउ आई वांट टू फाइंड लिमिट पाई बाय 3 टू पाई बाय 2 cosecant 3 theta d theta. तो फॉर दिस आई नीड टू पुट n is equal to 3. So I am putting n equal to 3 and replacing x by theta. So this integral is equal to pi by 3 to pi by 2 cosecant cube theta d theta, which is equal to, यहाँ देखिए, in place of n you will put 3, तो 3 minus 2 it is 1, तो this is 2 under root 3 and this is under root 3 power 1, तो under root 3 into under root 3 this is 3 and 3 minus 1 this is 2. ठीक है, plus 3 minus 2 is 1, 3 minus 1 is 2, 3 minus 2 that is 1 dash. So I write it, this is equation number 3. तो here I need this value. तो ये जो फॉर्मूला जब आप लगा रहे हैं तो n minus 1 से डिवाइड है, तो दिस इज नॉट वैलिड फॉर n इज इक्वल टू 1. ठीक है, दिस इज ग्रेटर वैल्यू के लिए वैलिड होगा. तो वी कांट कैलकुलेट द वैल्यू ऑफ i1 डैश फ्रॉम दिस एक्सप्रेशन. फॉर दिस आई गो टू द डेफिनेशन. यहाँ देखिए, अगर मैं देखती हूँ ध्यान से, तो in डैश इज इक्वल टू पाई बाय 3 टू पाई बाय 2 cosecant n x dx है, तो i1 डैश थीटा कौन होगा? पाई बाय 3 टू पाई बाय 2 इंटीग्रेशन है ना, cosecant 1 थीटा d थीटा. I need the integration of cosecant theta d theta, and which is equal to log of mod of cosecant theta minus cot theta. So I am integrating this by this and taking the limit pi by 3 to pi by 2. Again using the value of putting the upper limit and lower limit. When I put pi by 2 here, this cot is 0. Cosecant pi by 2 value is 1. So this is log 1 minus. Put your lower limit, cosecant pi by 3 minus cot of pi by 3. So log 1 is 0. So this is minus log of, in place of cosecant pi by 3 we can put 2 by under root 3 minus cot pi by 3 is 1 by under root 2. Taking the LCM, this is 2 minus 1, so 1 by under root 3. Now I am using the formula log m by log n. Log m by log of n, this is nothing but log of m minus log of n. ठीक है ना? तो use this. Again this gives you log 1 minus log of under root 3. Log 1 again 0. So this 0, this minus minus is plus. This is log of under root 3. I am using the formula log of m power n. It is n log of m. So this is under root power is 1 by 2. So it gives 1 by 2 log of 2. Write down this is equation number 4. Use this for equation back in the equation number 3. So it is integration pi by 3 to pi by 2 cosecant cube theta d theta, which is equal to, देखो वहाँ पे था 2 by 3 into 2, तो 2 to 2 cancel, तो 1 by 3, 1 by 2, and here is the limit of I1 dash. This is 1 by 2 log of 3, which is the required answer. ठीक है, तो we successfully completed our 11 questions which cover the topic reduction formula for following integral, that is integration of secant nx, integration of cosecant nx, integration of cot nx, integration of tangent nx. So all the questions based on these reduction formulas. In the lecture lecture second, we will start the remaining reduction formulas. Thank you.